All right, I think we can get started. I'll give a brief introduction on how this working group started for the ones that were not at the core dev call where I gave the announcement. So like around December, Ansgar and I came together. We had discussed this before, but I really had the conversation in December at this CCE conference where we both were. I had been looking into resource pricing, mainly on the research side. Like we wrote a couple of papers with some collaborators, and then more recently, last year in May, when Vitalik published the latest blog post on like multi-resource pricing, like kind of started thinking about how to implement it, like do an EIP more kind of the applied angle, not just the research angle. And then Ansgar was thinking a lot about like more short-term pricing changes, but also wanted to kind of have a framework to maybe do some more principled benchmarking and kind of upgrade like the way we've been doing like short-term pricing changes. So that's kind of how this came to be. And I think the plan for this group is to have like kind of a similar focus, right? Like very applied, as you saw in the outline. Today we're gonna discuss like show like some of the work that people did around benchmarking already. Then Ansgar wanted to like lead this discussion on like short-term changes, which is like something that we can target like in the next available fork or the one after. And then in parallel, we also want to like do a kind of more research angle. So like today, there's going to be one presentation around some initial analysis on a multidimensional pricing mechanism. And I think it's interesting to couple these because like I think a lot of the short-term changes that we will do and the analysis for those can also help with like the more kind of like this multidimensional EIP that is kind of like aspirational for now, but we should like work towards it. Yeah, so today is kind of like mostly like sharing like different work going on, but the idea is that we should try to keep this like very concrete, and then like as we progress towards the working group, like started also drafting a few EIPs for like the short-term changes, and then like hopefully we get to also push the bigger multidimensional change later. Yeah, so I think we can start with Marek and presentation that you wanted to share. Yeah.
Yeah, hello. Do you see my screen?
Yes.
Okay, great. So hi everyone. I will spend about 5 minutes discussing the tooling we developed at Nethermind. This tool could be used for gas pricing or might inspire someone to contribute or create something better. There is definitely room for improvement and it still requires a lot of work. I'm happy to discuss it further after this breakout. So the idea is very simple. We can construct any block and measure its execution time, and with enough testing coverage, we will better understand the current worst case scenarios, gas pricing issues, and the limits of how far we can push the gas limit and where we have bottlenecks. So for example, we can fill a block entirely with a ketchup or any other operation to consume all the available gas limit in the block. So very briefly, how it works. We have a test generator where any EL could be used. We just need to produce blocks. Of course, we use Nethermind. This test generator creates different testing files with engine API requests. And then we have a tool that sends those requests to different ELs, gather their results, and later produces a report from this execution. So using engine API has a few benefits. It is as close as possible to production, measuring not only the operation itself, but also everything surrounding it. For example, opcode execution might be fast, but the EVM instruction loop or the JSON serialization of engine API requests or something else could become bottleneck. One more benefit, it potentially allows testing any given blocks, including a combination of opcodes on any database. So we can use a mainnet snapshot to benchmark SS store, as load on the mainnet state. This is not ready in the tool, but it could be used in this way. And moreover, the engine API can work with any client, so including the future Ethereum clients, it doesn't require changes in the clients. Disadvantages, so this is less accurate than measuring opcodes in isolation, and generalized input limits the use of language-specific benchmarking tools like benchmark.net, so which are very important for accurate measurements, and they are doing a lot of important tasks like warm-up required for some programming languages. So we have to replicate this work in the tooling. And of course, building all the test cases is very time consuming. And now findings. So some precompiles might be problematic with gas limit increases, EC add, EC pairing, and especially ModExp. And they are relatively slow compared to other operations. We found a few bugs, such as issues in serialization in a few clients, and blob-based fee opcode was slow in one of the client. Those things are fixed now. And this tool highlights differences in gas pricing. For example, let's take a look at the table on the slide. On the same machine and with the same clients, the differences are significant. This might not be surprising for anyone, but it could impact us as the gas limit increases on L1 or become problematic for any EVM-based L2 that want to increase the gas limit significantly. So the slowest operation will always be a bottleneck. Unfortunately, sometimes it might be a hidden bottleneck that is not observed with real normal transaction on the nodes. Okay, and just I also want to briefly mention other work related to gas pricing. So Nethermind tool has both advantages and disadvantages and still requires further development. So let's take a look at other solutions. And the gas cost estimator is, in my opinion, the most comprehensive analysis currently available. It measures opcodes in isolation, so different approach than we have, and producing very interesting report. Actually, Jacek Glenn will tell more about it today. I also know that Flashbot's team has started building their own solution. I believe it's relatively new.
Nothing.
Sorry? Okay, I will continue. But it might be interesting to explore it as a test generator combined with our Nethermind gas benchmarks. Finally, there is an approach that has been used for gas pricing right now. So for example, in the recent BLS precompiled pricing, so this involves using test vectors where each client assesses gas pricing independently and cross-verifies results with other clients. However, this is very time-consuming, and the test vector format is not 100% standardized. It is kind of difficult to run different clients. Okay, so yeah, my presentation focused more on different approaches to benchmarking rather than on sharing results. I wanted to open a discussion about the tooling for gas pricing, and that's all I want to share for today. Thank you for listening.
Thanks, Mark. I think we can have this discussion on the tooling maybe after Jacek's presentation. One question I had is like, you presented the tooling, but you also did like some analysis and like some finding. Like on those, like, do you already have plans to kind of like propose some changes, or it's kind of like early stage analysis that like may require some like more effort or more help from the group as well?
Yes, so first of all, a few things were already addressed between the client teams. And secondly, the most important finding, I expect that we we will share EIP very soon. I don't know, within 2 weeks or something like that, with our proposal how to adjust one of the operation. And this is like the most important finding from all of them. Yeah, so we are actually right now addressing the findings, and maybe later I will just share some kind of report from this benchmarking work. Yeah.
Cool. Thank you. Yeah, Amesian.
Yeah, just wanted to add, so first, thanks, Malak, for the presentation. So we used Nethermind tests because we wanted to reproduce and check the numbers on our machines. And we changed the test itself, like the benchmark, to add CPU profiling on Besu. And it helped actually to improve some of the opcodes that was raised by the Nethermind report. So thanks for that.
I think we can proceed with Jacek presentation.
Okay, sure. Let me just share some presentation with you. Okay, can you see it?
Yes.
Okay, so our project is a gas cost estimator, and the aim is, as Marek pointed out, slightly, well, the approach is slightly different to what Nethermind did. So we want to test EVM implementations in isolation, and we want to use specific language native tools in order to actually get how computationally expensive each opcode or precompile is. So the goals for the near future is to provide a proposal for the new gas cost schedule. But going forward, we want to have a tool which allows people to monitor how things changes, or when we propose a new opcode precompile, how to specify a cost for this precompile. So the scope that we have, we took 7 most popular clients, all the opcodes, all the current precompiles, and based on that, we generated 50,000 bytecode programs which test opcodes and precompiles under various conditions with various arguments in different composition and so on. And we ran it for a very, very long time. I think to run the whole suite, it takes like 2 or 3 weeks, and we did it multiple times. And that gives us some, okay. The cutoff point, we needed to have some cutoff point in order to come up with initial proposal. So we took this 7 clients and the current versions as of November 24, and we ran all of those benchmarks and came up with some results for each client. So in this example, this is GEF, and it shows you that this it somehow validates that our approach was at least gives consistent results, right? So for each for most of the opcodes, the variety is not that big, apart from some log or calls.
Mike, you want a coffee? Or
Matt, you're unmuted.
Okay, so we have this low results, and then the question is what we do with the low results. So we need to normalize them somehow, and that's what we did after the long discussions and different tries out. We figure out is we take each client and scale it into the current gas cost. By scaling, we define the scaling as an optimization problem to fit one graph in the best way into another. We made some decisions how to do this scaling and how to recalculate it and so on. The end result is something like this. So it's a graph which shows you differences between each client implementation for each opcode and precompile. And now, once we, of course, this is a graphical representation. The actual data behind this is more concrete than just some colorful dots on a graph. But by analyzing this, we can come up to our first point. So propose a new gas cost. So we have some numbers here. These are not finalized because I still need to update it to the latest results, but it won't be very much off from the current things. So we in fact have two proposals. One is something that we call conservative. So we try to minimize number of changes, only to highlight opcodes which are definitely under or overpriced. So in this case, you can see that our calculations pointed out that MoolMod is underpriced, and pop and stack operations are overpriced, and we can lower the cost. The same goes to the new tload and tstore opcodes, and so on. And we have a similar comparison for the precompiles. As many people pointed out previously, EC recover and point evaluation are hugely underpriced in the current scheme. So that's one proposal that we have. The second one is more radical, that we say we don't look at the current gas cost. We want to start from clean sheet. For the arithmetic opcodes, we want to use 1, and then gradually increase the cost as we find the more computational costly opcodes. So as you see, the simple opcodes are 1, apart from some that are 2, and so on and so on. This is more radical, as most of the opcodes will end up having a 1 or 2 gas cost. Now, when you think about the result or consequences of such a move, if we lower the cost of all the opcodes and leave the storage cost or state cost at the same level, we widen the gap, so it becomes less costly to compute stuff and more costly to store stuff, which is probably something we want, but it's up to discussion. Just one last thing, we did the same thing for all the precompiles, and we probably will do for the new BLS precompile as well. Okay, so that's it.
Thanks, Jacek. This is very interesting analysis. Thanks for sharing it. For whom is not seeing it, I think super interesting. There is one question from Kevandra in the chat asking, do the benchmarks that relate to loading from storage take into account storage growth?
Now, the storage is very difficult to benchmark, especially if you want to do it in isolation. So for any storage cost, so in our assumptions, all the storage is warm, so it's already somewhere in the memory or in the cache. And we only want to calculate the computational and operational costs. For the storage as such, the Marex and Nethermind's approach would be probably better because you have the actual client running there and you measure the client, not the EVM in isolation.
I see. Is there a question from someone else?
I can make a comment that it could be doable, but the effort to prepare the context for such tests that are testing storage opcodes in a proper good manner, it would cost a lot of a lot of effort. And as Jacek said, it seems that Marek's approach is slightly better in that case.
That makes sense. Yeah, I guess I was also wondering about the modifications that need to be done to clients. Using Marek's one, it's basically just a Docker file. So you don't actually modify the clients at all. With this approach, are modifications needed into the clients?
There are few modifications, and we probably will ask a client implementation team to include those modifications into the code base. But not big, it's just mostly to allow some benchmarking.
I assume cold S store and cold S load aside. Warm S load would probably be the same as T store. T load, sorry.
Good question. It might be slightly different. Trying to find out here, but yeah, something we can figure out later. I need to update my numbers first of all to the latest results, and then we can analyze this.
Cool. Yeah. Yes, like maybe you can share in the group once you update, and then we can schedule another.
We'll definitely do. Yeah, it should happen this week, so fairly soon.
Thanks. I think we can move maybe to the second part where Ansgar wanted to like present, like discuss like some of the short-term changes related also to this.
Yeah, sure. One sec. Can you hear me?
Yes.
Yep.
Awesome. Yeah. So for this section, like it's I have less to present. It's not really about presenting. I just wanted to basically have some questions to discuss with the group. And so I just bring them up, I guess, one by one, and we can just talk about them. So I think basically as David was just saying, right, like there's both the questions of like what is our strategy here medium term over the next 3, 4, 5 hard forks, but then also specifically what can we do for Fusaka or Amsterdam. And there specifically, I think it on the pricing side, it seems like this kind of this just one-time repricing effort that we just talked about with the benchmark seems like a very strong candidate. And so there, I just wanted to talk a little about the different points we would have and decisions that would have to be made. So the first one, of course, would be to me, there's like three different types of repricing. There's just the opcodes among each other. That's in a way like the least controversial, right? So we basically just do the relative setting of the opcode prices to each other a little bit differently. Then we can also like try to harmonize that with precompiles. That is, I personally think would be quite important actually to have like one shared kind of compute cost across all of those. And then the question is also, do we in general just want to allow for more compute in the block, right? So basically just what I would say, like from the report just now, the more aggressive option, basically, do we basically not just relatively make the pricing different, but actually basically allow for more compute in the block? So first of all, basically just like be curious how people think about these questions, like what should this initial repricing have as a goal? How much do we want to go there?
I guess it makes sense to reprice everything so they're balanced and possibly remove any that are not needed, but maybe that's a bit more radical.
Right. Dragan?
I feel that it depends on the impact of the repricing. If we reprice all the opcodes and the difference on the block size is 5% or 10%, I'm just like giving the numbers, then maybe it doesn't make sense. If we can reprice some opcodes and the impact is like 50%, we can like double the block size without increasing the gas, then maybe it would make sense to reprice it. But for that, to get the information, we need to have like to see how much the top code is used and how much basically sample the data from the chain.
Right. So if I can understand that correctly, what you're saying is basically we would need to get some metrics on, given any specific new pricing schedule, what would the actual real world impact given today's kind of usage be like? Is that what you're saying?
Yeah. Even if something is priced incorrectly, it will not. If there is no incentive to change it, we can live with it. If something has some opcode that's not that much used, then we are fine to not change the price. But I'm saying this in the context, changing price of any opcode is basically the big change.
Makes sense. Ben?
I'd see the more radical approach as sensible. However, we need to bear in mind that it would potentially increase block size by allowing more transactions through. So we need to make sure the handling was done there. But hopefully call data size fixes that.
And there your concern is basically that it would increase the average size of blocks, right? Because the worst case size would not be affected because we wouldn't actually increase the gas limit, and so the call data price would be unaffected. But you're saying basically because compute gets cheaper, there's just more room, and so the average block size would go up. Is that right?
Yes, and also the maximum block size would go up. But however, that's being brought down by the change in Petra. But we just need to be cognizant of it. That's all.
I see. Basically, you're saying if we, in addition to making pricing changes, we also just increase the gas limit. Is that what you're talking about?
No, I mean with the current gas limit, if all the opcodes drop in gas price, well, most of them drop in gas price. Assume we'd keep the cold storage the same. Say, then there would be you'd be able to put more transactions in the block. Therefore, that would increase the block size. But hopefully that's been countered. So I'm not worried about the block size increasing. I'm worried about hitting any limits. For instance, we're worried about 36 million gas being the current limit. If that makes sense.
Yeah, but I think so that was another kind of point I wanted to talk about. Like to me, it seems like a good idea that we would focus, that we just restrict the initial set of changes to only pure or almost pure compute operations, opcodes and precompiles. I think there is definitely this larger effort that we should also in parallel run of like basically having a well-defined kind of now new set of pricing across all types of dimensions, including the storage opcodes and including the data and everything. But to me, it feels like it might just be a bit more defined scope and something we can have more confidence over if we initially only focus on the compute opcodes. And so the worst case block size would be unaffected, the worst case state growth rate would be unaffected, these kind of things. Is that a reasonable assumption, or do people think that would not be the right initial scope to focus on, or?
it would still increase the block size by allowing more transactions. So your current transaction would cost slightly less in gas, therefore you'd be able to put an additional transaction in there. However, the current threat we have on block size, I think, should be mitigated by the Pectra change to call data, so it should be fine. But it's just something to bear in mind.
Yeah, there's definitely like basically increased average caseload at the very least. Okay, that's reasonable. So it sounds like people in general have an appetite for basically allowing for more, not just basically making sure that we actually harmonize the prices across compute, but we also actually can make compute as a unit cheaper. So far, most proposals that I've seen have focused on basically using one gas as the kind of the new floor gas price. But of course, that means that there's only so far you can go in terms of making compute cheaper relative to the other opcodes. I was curious if people, so there have been these old ideas around. I don't know, Axik, maybe I think you're on the call, right? There was, can you remind us of there were these old ideas around having basically like, what was the name again? Some other unit of gas that's basically like milligas or something, but it had some nicer Ethereum type name, no?
The name was particle gas cost or fractional, but yeah, you can call it anything.
Right. And I feel like you probably have the best, the highest context out of all of us. Like, is there, was this like an idea that was more like a kind of like someone just put a name on it and that's it, or did that already have like some sort of work behind it, or how that could look like?
Yeah, we have an EIP for it as well. And the main goal was to have more precision on the really cheap instructions where you would go below 1.
Right.
And
so
the
basically,
alternative to that, I think as I mentioned the last one, let me try to, yeah, so 2045. The alternative to that, if you want to go below 1, and if you don't go below 1, then you can just scale up everything else. So that's the other option.
right, exactly. So basically, like that's so for those maybe that haven't heard of this particle fractional. I mean, hopefully the intuition is relatively simple. It's just about tracking, basically giving opcodes, say a gas cost of 0.1 gas or something, and you do that by basically having a unit that's more fine-grained, and that basically accumulates, and then once it ticks over a full gas, basically the actual transaction gas gets reduced, or some version of this. You can have a look at the AP. Actually, I will have a look at the AP. I didn't. I forgot that was already in the AP stage. That's really nice. And so indeed, basically, I think we have 3 options here. Either we basically just accept that we go to 1 as the cheapest unit, and then we just have everything else scaled up from there. And then that means we just have like some sort of modest increase in compute headroom that gives us. Or we basically use fractional gas to be able to have the base be even lower than 1, and then everything else kind of relative to that. So that way we could basically scale compute room up to whatever we feel like, however much gas we feel, or however much compute we feel comfortable with in a block. Or the third option, as Alex was just saying, indeed would be to basically just have everything on the compute side be based on like 1 as the lowest price, but then basically just like increase the gas limit overall and offset that by making all the non-compute operations more expensive in proportion. And to me, that seems like, in a way, the most heavy-handed approach, because you need to change all of these other prices as well. But I'd be curious, basically, again, that's like, and to me, basically, again, this call is more like about like
When did you come on?
pointing out all these kind of decision points that we have, and maybe already starting to collect some opinions of how people feel like we should go. So here again, I would be curious, basically, just a modest increase, a larger increase with fractional, or a larger increase by making everything else more expensive. How do people feel about this? Alex?
Yeah, so when we were looking at this, I mean, each of them had pros and cons. But I think the complexity of execution, especially combined with the new consensus layer, is such that the third option, I think, would be just way too much, because you not only have to change the prices of basically every single instruction, but all the different limits and everything around, transactional block limits, and this also slips into consensus. So I think this last option is probably something not worth doing.
Right. That matches my intuition as well. Is there something where we feel like maybe we would benefit from some metrics, basically saying like, hey, if we go with the basically the best we could do in terms of relative pricing of compute based on like one gas as the lowest price, and then we look at how much extra throughput that would get us, and how much basically worst case compute like execution time for the block, and then we see whether that seems reasonable or whether we would want to go beyond that. Is that something that we think should be more of a metrics driven question, or how would we concretely make progress on making that decision for the upcoming forks? And if no one has a strong opinion, then I would just say that like I think metrics would be the way to go. And so then we are basically back to what we talked just on the earlier point as well, that I think one type of metric that would be really valuable to inform a lot of this would just be well, one, of course, kind of just a worst case, like how much can a compute only block, how much basically execution time could it take, but then also how much impact would any given type of pricing change have on real world usage, like how much more throughput would we be able to have in a typical mainnet block. So those I think are in terms of on the metric side good kind of follow-ups already. Yeah, then moving to the next point I wanted to touch on, basically a big concern that has been raised in the past every time repricings have come up, that especially repricings that touch many opcodes or many different types of operations in the EVM, has been backwards compatibility. In the past, I think the Ethereum mainnet approach has mostly been, we are so unwilling to risk breaking any existing contracts that we would rather basically make rather limit the changes we make to the bare minimum. It feels like this comes really into clash with this effort here, because it's actually not so easy to even get visibility on what exactly the backwards compatibility concerns here are for existing smart contracts that might have hard-coded gas values in some places. That's a pretty thorny effort to analyze well across all of mainnet contracts. And then B, also, it just really kind of slows down any velocity of change here if we basically have to be very careful with this. On the other hand, of course, even just risking breaking any kind of contracts on mainnet as kind of weird and edge casey as they might be, is of course not a good look. So I would actually be curious here, for people that have kind of that have been confronted with that issue in the past, maybe around pricing changes, maybe talk a little about like how we've been dealing with this so far, and then B, how people here in the group think about to what extent we should basically be focused on limiting backwards compatibility concerns. And basically, yeah. Okay, good. Because I was about to say, if no one has an opinion, then that my default opinion that I'll set for the group is we don't care at all about backward compatibility. So if you disagree, you should speak up. And Ben?
So I think increasing prices is more problematic than decreasing prices, because then you're going to hit unexpected out of gas more often. However, historically, I mean, the prices have been increased several times, and that was like where access lists came in as like an escape hatch to allow certain spot contracts to still work. So we have historically broken things by increasing prices, but I think the risk with decreasing prices is a lot lower.
That's reasonable. But I mean, I feel like in some sense, access list is a counterexample because yes, we were willing to break something, but we paid a very, very, very large extra cost of making sure that even the small amount of potentially affected contracts would have an escape hatch, by introducing access lists, which have not had any real world use other than that basically since. So I feel like that specifically would be the kind of approach here that would slow us down a lot if we wanted to be as careful about it as that. But you have a good point that of course here the main impact would be making things cheaper. Yeah. So I guess I take it as that no one in the group is overly worried about backwards compatibility. Is that reasonable?
If you wanted to be really spicy, you could say that only EOF had a lower gas pressure.
Yeah, that was actually the last point I wanted to bring up, EOF. So we can jump to that in a sec. But yeah, first, Dragan.
In general, it's inevitable. We'll break gas in the future, and we should break it. It's not we should try to mitigate some breakages, but in the end, this is not something that we can go around. I feel there is like two types of the breakages that we can like basically do with the gas changes. One is different gas price, gas opcode result is like it's a different value pushed to the stack. There's nothing that we can do about it. The second thing is different gas limit sent to the calls. I feel that we could increase that gas limit by some amount. Like every gas limit that is set for sub call, let's increase it by 2 times. Then any gas that gets increased, any gas for the opcode that got increased will at least mitigate some breakages on that part. But either way, yeah, it's inevitable.
Yeah, I think that personally very much reflects my own opinion on this as well. Tony, do you have a take on that?
Yes, I agree with that. I think we shouldn't be limited by backwards compatibility. The only thing is that we should at least be aware what things we break and that we kind of understand the impact.
Right. Historically, this again, in my memory, has been a relatively hard challenge, getting a really good understanding of the entire breadth of mainnet contracts and how they could possibly be affected in different edge cases. Tony, do you have any specific kind of idea of how to try to have as high a visibility on this as possible, or how you'd approach this, or is it just something that requires more attention, more study?
I would just look at the transactions. For example, if let's say the last year has had no transaction from a certain contract that uses some opcodes in a very fancy way, then we might just ignore it. But of course, that's difficult, right? Because we don't know if very old contracts might be used in the future for a very unique use case, unlocking some funds or something. But yeah, for 7623 at least, we basically looked into a specific range, date range, and checked all the transactions, who would be affected and who not. I mean, it's only relevant if we would increase the cost of an opcode, for example, to something where you could not even call it a few more times in a transaction. I don't know. It's difficult. But I think just looking into the transactions and checking if they're using certain opcodes or not should be enough.
Yeah, that seems reasonable. Although there is the tricky bit that like, so basically naively, you could just think, well, you just take the new pricing schedule and you just rerun the last year of transactions and you see if any of them would have any subcalls that now ran out of gas that did not previously run out of gas, or vice versa, that basically had some sort of hard-coded gas that they sent into those subcalls. That could be interesting, but there are complexities around that because, of course, you can have logic that branches on the exact amount of gas available, and so you actually have to, it basically you have to get the analysis right. It's not quite as easy as just rerunning and seeing if anything changes behavior around subcodes running out of gas. But I think in principle that is a reasonable approach to identifying impact. Yeah, that sounds right. Okay, sounds like if there's also some messages in chat. I'm not sure if anyone looks like too much for me to all read now. So unless anyone wants to bring anything up on the call itself, then yeah, the next item that I had was specifically around EOF. Maybe if someone from the EOF people, Axic or I think we have several on here on the call. If you want to talk a little bit maybe about the potential ideas around limiting some or all of those pricing changes to the newly introduced EOF contracts, and then we can maybe could afterwards discuss whether that is a consideration that would be we would want to continue exploring.
So one of the things EOF has as part of its guiding principles is to reduce gas introspection, which is the ability to say, I want to limit this amount of gas that I send to my next call, and I want to see how much gas I have remaining. A lot of the contracts that we've seen that have been broken, things like when we did the increase into the storage costs, there were a lot of contracts that hard-coded certain values as a presumption. And that since that breakage has happened, that's become an auditor recommendation, is never hard-code gas values. But as far as changing the gas schedule in EOF, because you don't have any way to react to it, changing it within EOF shouldn't be a problem based on the old or the new gas schedules. And if it is changed and it does become a problem, the solution is simple. You just increase the amount of gas that you pass into the system because there's no way to lock in lesser amounts. And that's for EOF contracts. Anything that goes through legacy contracts, as long as they don't limit the gas being passed in, if there's an increase or decrease in EOF, then any changes in EOF, the solution ultimately would be to just increase the gas in your transaction and things should start working, which was not an option the last time you increased it because you could limit your gas to like 35,000 when you do your call, which was something we ran into. But as far as the gas schedule, I mean, the idea that we could tie it as the initial feature of EOF is something I'm resistant to because there's a lot of things that might hold that back. Because the idea of gas pricing is fairly orthogonal to EOF packaging. And we could make these decisions about what we want the prices to be and ship them in a later fork, even as a compatible soft fork. We don't even have to change the version, and we can just change the schedule. But there's also, I think, a higher level issue, which I think was mentioned in the text of the of one of the radical proposals, is that clients are not necessarily tooled up to do radical gas schedule changes on this level. And so any proposal that we would do would need to spend time reworking the clients to make sure that they can handle very radical gas schedules between different forks. And if we limit it to EOF, radical gas schedules within forks that are different. So there's a risk there of limiting it to EOF. So while there is value in limiting the changes to the EOF and it's tooled up for it, it brings in risk that I think it makes it question whether we should go down that path or not.
Right. So yeah, so basically like with EOF, I think there's these two aspects. There's the aspect of like EOF itself is nicely designed so that in the future, basically pricing changes are just very painless. And we don't have to worry about these backward compatibility issues. which I mean I think is one of the many kind of elegant aspects of UF. And then there's this kind of the separate question just around given that, and given of course that we could want to incentivize UF adoption in some way, is there any reason to explore only like bringing at least parts of these pricing changes only to UF basically? So UF would go live in the next fork anyway, presumably, and then it could basically have a different pricing schedule, a more attractive pricing schedule. I personally, my opinion on that would be that I just think that in a way, kind of like giving a one more throughput is an important enough priority that I would prefer if that is not blocked by kind of however long it takes for the ecosystem to start moving most of the activity over to UF. So I would personally prefer if we also bring all kind of cheaper pricing to existing legacy bytecode, but I'd be curious if there's disagreement on that, or if people actually think that maybe limiting some of that to UF only could be an attractive option. Roman?
My personal preference would be for anything storage related to be agnostic of whether we include this in EOF, like for it to be applied to both legacy and EOF contracts, and any operation specifics to go in package with EOF. And to answer the comment in the chat that EOF change is big already, I think that should be a separate discussion, whether we package anything with the next hard fork or we start introducing in the hard fork after EOF.
Yeah, I agree with I think both parts of the statement, but yeah, in particular, that's why I think Davide also framed it in the beginning as like, say, this section talking about what we can do in the next 2 hard forks, because I think we should have that discussion. It's an important discussion, and we can have that over the next few months. But I think for now, basically, we just assume that like whatever the next slot is that opens up for like short-term pricing changes, what should our strategy be there? And of course, maybe there's a little bit more room or maybe a little bit more we could get done if it's 2 forks out than if it's 1 fork out. But I think in principle, for now, I think the best approach is to just assume either of those 2 forks. Right. So I only just now noticed that we're already like close to running out of time. Roman, if you wanted to say one more thing about this.
Yeah, just one quick thing that my personal preference would be to deal with all of the storage opcodes and block level repricing in whatever the next slot is, and we can tackle everything else later.
Yeah, that seems like one potential reasonable approach. Again, I don't think like today is quite the right call yet to make any decisions or even anything like that. But yeah, that seems like a reasonable strategy. Yeah, I just realized that we're already 5 minutes before the end of the call. There was this entire kind of section on the more medium term kind of roadmap here. I feel like maybe we more realistically have to kind of have like another breakout call at some point about this anyway. But just to briefly wrap up this section, the one thing I just wanted to last say on short-term changes. So far, we only talked exclusively about compute repricing, which I think is like an important pillar of the things that we can do in the short term. I wanted to briefly talk about if there's basically other things short term that people would want to already consider. Roman already basically touched on this right now, but so the 2 things that I saw was basically the gas sheltering and basically some simple modifications to storage. And so maybe, I don't know, and I know that from the Netherlands side, there's been work on the gas sheltering. So maybe if you could very briefly kind of summarize that, because that seems like a very reasonable candidate for an upcoming fork.
Yeah, so gas smuggling is where so when you're so we get refunds by setting things to 0, which is a good incentive on the transaction level. However, the way it works is that also comes off the used gas in the block. And setting something to 0 is just as expensive for the EL as setting it to anything else. So the idea is you'd still get the refund. However, the refunds wouldn't count against, wouldn't come off the amount of gas used in the block. So at the moment, you can say if we have a 30 million gas, with refunds, you can take it up a block up to 36 million gas. And the idea is we should get rid of the refunds coming off the amount of going back on, decreasing the amount of gas used in the block so that the block limit is the block limit, if that makes sense, rather than, because it gets worse as the gas block size increases. So, at 60 million gas, it'll be 60 over by 6 million gas that you can refund through. That's the idea.
Yeah, and I personally think that makes like a lot of sense to address. I know Barnaby had some kind of work looking into the kind of the more kind of theoretical implications of such an approach, and had some, I mean, maybe not concerns, but there basically some nuances. I'm not sure. Maybe now is not the time to go into them. So, but I just wanted to flag that's something that so where we still have to double check that basically we have a good grasp on how to best make sure this is fully addressed. But I think in principle that's a reasonable candidate. And then the last thing I wanted to briefly touch on was the general kind of topic of state repricing. The one thing that I have been focused on there a little bit, like Tony and I have a draft EIP almost ready that would basically that's all about block level warming. Tony, do you want to summarize that in like
yeah, I can do so. Yeah, basically treating storage slots and addresses as warm if they have been already touched in an earlier transaction. So this is kind of the TLDR. And I've been doing some analysis and it looks like we could gain about 5 to 6%. Sounds reasonable, I would say. It's not that much, but yeah. Another thing that would be interesting is thinking about which might be more complex, but also more promising, which is multi-block warming, kind of keeping a window of warm slot open for a certain amount of blocks. And doing so, let's say we do a window of 15 blocks, then we have around 15% of efficiency gains. So this is then quite significant, I would say. But yeah, the first step might be to just warm on a block level and then move forward.
Yeah, and Storm from the Wrath side had a really good analysis, I think, on this recently, right? There's kind of this potential for multi-block warming, caching basically of state, which yes, multi-block is a bit of a thorny issue. So I think that should not be on the short-term changes path, but I think the single block warming is a very reasonable candidate. Pavel?
I'm not sure how much time do we have, but I don't see how this multi-block or like even single block warming increases throughput. It just calculates the cost differently, but the throughput is the same.
Well, no, it does increase throughput because a transaction that touches state that already the transaction before it touched now basically gets charged. I mean, it depends on how you implement it, right? Whether you implement it with refunds or you implement it with.
It's maybe it's charged unfairly, but you can just increase the gas limit and you will get the same throughput increase instead of counting gas differently. In the end, it will do the same work on the database. It just have different accounting for it, and that's it.
Right. Yeah.
I mean, unless you mean it will incentivize like huge contracts to like kind of traffic all the I mean to take all the traffic through some like basic contracts. that will aggregate everything. I'm not sure that's actually desirable, like goal, but yeah, I mean, this kind of incentivize like big applications because they will be cheaper. But besides that, you have the same database work to do anyway. So you just modified the like accounting, but didn't improve anything.
Yeah, I mean, I think actually this is reasonable, and like as you said at the beginning, unfortunately, like we're just literally out of time, so like we can't really get into this anymore. I do think that like there's an interesting conversation here because yes, what you're doing is by just expressing the underlying cost for the system a bit better, that you're just incentivizing now more behavior that is now cheaper priced, and so then over time the mix changes and you basically do have more throughput. But indeed, depending on how you do it, you wouldn't immediately have more throughput using the existing mix. So that there's some nuance there. So I don't, but yeah, we're out of time, so we'd have to have another call to go into this, and then also the longer term kind of things that Davide would wanted to talk about more. Maybe last thing, Kev, if you wanted to say something.
Yeah, I was just going to say what I wrote in the chat. The TLDR is maybe possibly we could consider pricing for ZK proving as well. There are some opcodes which are cheap in the CPU, but are harder to prove, create a ZK proof for, like Ketrach, for example. I think there's an EIP out that Vitalik made, so I don't remember the number, that like 10x Ketrach to account for something like this.
Yeah, I mean, again, out of time. And this is, I think, a really important conversation because I don't think it's obvious at all that we should do it, but it would be an opinionated thing and would have a lot of benefits, but also would be quite costly. So this is something we need to have that conversation though before we ship any pricing changes, right? If we touch pricing here anyway, we need to have it embedded in like a long-term strategy, and that includes the ZK strategy for L1. I agree with that. We're out of time there. Davide, do you want to like close us out? Sorry that I stole your like time slot for the
No.
for the
I
last
think this was like
section.
an interesting, much needed conversation. Yeah. And I think like the ZK proving related changes, they kind of fit into the midterm changes that we can discuss in next call. Yeah. So thanks everyone for joining today. We'll probably schedule the next call to like follow up on like various topics discussed today and then go more deeper into the midterm changes. Yeah.
Sounds good. And in terms of concrete takeaways, the one thing that I remember was that like I think it would be really nice if we would have tooling of like assuming this different pricing schedule, how much impact would today's mainnet throughput? How much would that basically impact today's mainnet throughput? I think that would be one thing that would be really nice to have. And then otherwise, yeah, I think primarily the value was in syncing people, but awesome. Okay, then bye everyone, and we'll have to continue this topic. Exciting.
It's follow up. Yeah. Thank you.
Thank you.
Thank you
See
all.
you.
Bye bye.
Bye.
Thank you. Bye.